now my body is charged to ouch! Damn.
Dude, I should probably wear one of those all the time. Today we're going to be looking at another one of ElectroBOOM's videos. Specifically the Mehdi-Van-HURT machine. Oh boy. For those of you who don't know me, I'm Tyler Folse. I'm a nuclear engineer with a little over 10 years of experience in the commercial nuclear power industry. From engineering operations to emergency response. I don't claim to know everything there is nuclear, but I can certainly share some knowledge. Let's see what this is.
Hi! I suddenly had this brilliant idea for a new invention to combine two famous contraptions into one. A bandograph and a Mehdi-Van-HURT generator. And significantly increase the charge pumping action. That was a stroke of genius by yours truly. Of course.
Now what's he going to do with all that voltage? I know you can use Van de Graaff generators to make small-scale particle accelerators, so if you increase the voltage further, is he going to make one? Also, how high is this voltage going to go? Are we going to accelerate electrons into targets to the point where they produce X-rays?
What each of these machines does is pump charges from one side to the other to create tens or hundreds of thousands of volts and powerful arcs like this. Smell around here. But
just sniffed an arc with a Van de Graaff. I mean, those make high voltage by using a moving belt to transfer charge to a large conducting sphere. They could theoretically get to millions of volts that way.
Since the maximum voltage you can achieve is a balance between the amount of charges being pumped and the charges leaking and escaping to the environment,
yes,
you can achieve a higher voltage the stronger we pump. And that's what my invention is about. Let's
giving yourself a stronger pump. All right.
Start building it. So my starting point is my pantyhose Van de Graaff machine that, as we know, if you turn it on, the pantyhose rubbing against the PVC pipe creates a charge difference. So if I hold on to the ground, somehow good length of arcs are jumping.
That is crazy. Can't say I've ever seen one like that used in a particle accelerator or a nuclear power plant, but...
Ow! Jeez! I'm being an idiot. I did make a ground ball for it. There we go. My monitor is shutting down every time it arcs.
Oh, yeah.
Let's see how far it can jump as a baseline. Ooh, perhaps a little bit over 2 inches. Does it jump longer to my hand? Ow! We jumped that far? Oh, look at that. It
says so much about his confidence that he's willing to put his skin and his hand on the line for something like this.
See it? It's more than 3 inches. Ow! That was far. It's jumping over 6 inches now that I'm just pointing my finger. This indicates how charges accumulate on a pointy object. Oh. And if it is not pointy, ouch. Ow!
How to turn your finger into a lightning rod, basically.
Get the point. Now let's see if I can add some Mehdi-Van-HURT into my bandograph. I have some plans. First, I want to cut some pieces from a brass rod. Like these, well sanded too, because, well, we don't want to damage our pantyhose. I also cut a piece of plexiglass I like to place between the belt to create some isolation between the two sides of the belt. I'll explain later. Just add some hot glue to hold it in place. Now we take some
He does so much with hot glue. I love it.
popsicle sticks. We hot glue these rods over the sticks. Then we are going to hot glue these to the posts, pushing the belts further towards the center. So
you know, using stuff like pantyhose, hot glue, and popsicle sticks, I know he's very knowledgeable about electricity and electrical engineering, but I love the fine line between you really need to know what you're doing for this to the equivalent of some kid's science fair project. It's fascinating to watch.
basically, you see, with these, I have pushed the two sides of the belt closer together, while the plexiglass is keeping them apart. Now I'm gonna cut some copper pieces out of my copper tape. I need both hands. We round their corners a bit. And we end up with copper pieces like these. We stick these copper pieces to the pantyhose, praying that the copper tape's adhesive is strong enough to hold on to the pantyhose. Okay, now we have copper tape pieces on both sides of the belt. Let's increase the voltage and give it a try.
Oh, got caught.
The hell? Oh, there you go. What is wrong with this? Damn it, the edges of these copper tapes get caught behind these thingies. Maybe I put some electric tape around it to make it a smoother surface like these, so those copper tapes can slide over this surface easier. So I made it better by adding these strips of duct tape to the edges of the copper so that they won't get caught. As long as we don't increase the speed too much. So because I can't run it as fast as before, it won't pump charge as much as before. So the arcs are smaller, but still decent. Now I added another wire to the ground with a ball at the end. And now, if I touch the belt on the side that is going up, it stopped arcing. This should increase the charge pumping action. Where are the arcs? If I let go, oh, they come back. The hell? Come on, man, this should make it better. It stops arcing. Are all my calculations wrong?
Ooh, that's something you never want to hear. And one of the reasons why most nuclear engineering applications you have a peer checker. I've never done anything where you were making calculations by yourself that were not checked or validated by somebody else or by some different process or something. On the subject of calculation for physics testing within a new reactor core, so you've had an outage, you've refueled the reactor, and you're about to start it up. Not only are they peer checked by someone for the company that operates the reactor, they are also modeled by a third party, especially for risk assessments, by an engineering consulting company, which is also peer checked by them. And then you compare the results. And then you validate the results in the field with the reactor operators just to be absolutely sure that your new core is doing what it's supposed to be doing. Not to mention all the calculations are super conservative, so you don't inadvertently produce too much heat or radiation in a zone that's not expecting it. Or in this case, give yourself too many shocks or arcs.
What if instead of directly touching the belt, I use a comb like this and come close? It dies right away. What the hell? This comb is the same thing as those brushes down there at the same voltage. How come they make it work, but this one kills it? Yeah, the arcs are gone.
I can't say I've ever requested a plant operator to comb the main generator to make sure it still works. That's awesome.
As soon as I remove the comb... what is going on? Okay, so watch this. We have arcs and we have this comb. Even me holding it up like this with so much distance from those bulbs stops the arcs. It is sucking enough charges to lower the voltage enough so that no arcs are happening. See, we have arcs.
It's got a lot of little pointy things on it.
I bring this here, not even close, and the arcs go away. Wow. And that's how lightning rods on top of a building can prevent lightning or make them weaker by...
Essentially by taking a teeny tiny thingy with a bunch of pointy things on it to take all your charges.
By sucking charges from clouds, reducing them.
Well,
this wasn't supposed to happen. What the hell, man? I spent a few days analyzing the shit out of these modifications and I was sure it was gonna work. I was even gonna name it Mehdi-Van-HURT, my new invention.
Oh, here we go. You combine them and then in the title, Mehdi-Van-HURT, because it causes a lot of pain. That is an interesting coincidence. I've seen that a few times in areas that it was not intended, such as Dingy Plumbing. Last name was Dingy.
Oh, there's an S there. What is it? Wimshurst? 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 Wimshurst, perhaps. Fine, I could call it Mehdi-Van-HURT and not to both inventions and how I put them together, but it's not working, is it? Let me explain what I was gonna do. So as I explained in my old video, Van de Graaff works by triboelectric effect. When two non-conductive materials rub against each other, charges from
I'm unbelievably immature.
one sticks to the other. In my case, I have pantyhose as belt that goes around PVC.
Nylon, yep.
When rubbed against each other, PVC sucks electrons from the pantyhose rotating belt.
Yeah, basic electrostatics.
Those electrons are picked up by some brush charging the top dome negative. The positive pantyhose rolls down and sucks electrons from Earth or some adjacent ball and becomes neutral again, going up. So it pumps charges from one side to the other. Wimshurst machine, on the other hand, has two circular plates rotating in opposite directions and some small metal plates on them that push and pull charges with capacitive coupling and yeah, it's more complicated. Rimstar.org has a great video explaining how it works.
Now, I don't claim to be an expert on either of these, but my understanding was the Van de Graaffs tend to give you more voltage than the Wimshurst, up to the order of millions versus tens to hundreds of thousands of volts. Though the idea of using a Wimshurst to pre-charge your Van de Graaff is interesting, which can boost the overall voltage and give you more pump, as he says.
Watch that. What I wanted to do was pushing the belt sides close to each other while keeping them isolated by some plexiglass. Then, similar to a Wimshurst machine, placed copper plates all the way around the belt.
Okay.
My thought process was, why neutralize the belt at the bottom and send it back up while I can pre-charge it with electrons? I could connect Earth to the belt.
Yeah, so not only could this give you faster charge accumulation on the top one, but it could just raise the overall voltage, more so than either device doing it by itself.
And electric fields from the positive side of the belt coming down would suck electrons into the opposite plates, charging them negative, going up. That way, not only I create negative charges by triboelectricity by PVC, I pump extra electrons.
It's interesting hearing something where you want to maximize the triboelectric effect. Normally, in the context of nuclear facilities, it's something that you just have to deal with, such as static buildup during assembly or disassembly of fuel rods. Because friction between the zirconium alloy and the handling equipment can generate static. And in certain high radiation environments, you can have radiation-induced ionization combined with surfaces that can accumulate charge. So you need to use grounding, anti-static materials, and carefully controlling the environment's humidity in order to minimize the accumulation of static, because it can really ruin your day. But here, you're actually maximizing it on purpose, which is interesting.
Into the top dome. Much high voltage, so much arc. But alas, for some reason, this has a negative effect. Anyway, my modification not only doesn't add charges to the side of the belt that is going up, it seems like it's making it weaker by removing electrons from it, because it doesn't arc anymore. If I just put it aside, there are arcs. I don't understand now. I wish there was a way for me to tell the charge amount on different surfaces so I could understand. Oh, actually, I have something, right? Yeah, I used this thing in my last video too. It's a device that tells the charge between your body and the environment. So this should be able to help. Okay, let's do a screen capture. So right now the voltage on my body is close to 0 and the bottom of the Van de Graaff and this ball are both connected to ground as well. Now,
okay, I usually see stuff like this in the context of mats, like in certain rooms that you really need to be careful about charge, and it's to essentially measure it so you're not the device that is causing arcs or static buildup on really sensitive electronic equipment.
I'm not touching any ground and I'm floating. Let's start the machine. Seems like my body is picking up some charge. Let me bring my hand close to the ball. Oh, the voltage on my body is going down. Those pulses are because the ball is discharging to the ground.
Sure.
If I bring my hand close, ouch! Jumping to my hand. Okay.
Oh, look at it go.
Okay, there you go. Now my body is charged to ouch!
Dude. Yeah, he should probably wear one of those all the time.
My leg discharged to the table. Now I'm not touching anything, and you can see that my body is becoming negative as I'm picking up charge from that ball. If I bring...
Interestingly enough, I've never seen one of these worn and using a and wearing a dosimeter at the same time. Could be interesting. Though, if you're going to be in a radiation field where it's going to have a significant impact on that, you probably shouldn't be in that radiation field.
In my hand close, I'm going more and more negative. Ow, okay. Nice, I'm close to minus 20,000 volts. Of course, as soon as I introduce my body, the voltage of the bulb drops significantly because the charges run away from my body. But as soon as I remove my body, the bulb's voltage rises more significantly because the charges don't run away through my body anymore. It is good for a relative measurement, so let's say the ball is at around minus 20,000 volts. Now I discharge myself. If I touch my side of the belt that is moving up, that's also negative. Okay. Negative 12,000 volts. How about the other side of the belt going down?
Yeah.
Oh,
there you go.
That side is more positive, which makes sense, but it is still in
there you go. Now put one hand on each side and see what happens.
negative range. So the side of the belt going up is already extra negative for some reason. So it makes sense why it doesn't work. Instead of letting those charges go up, I'm sucking them to ground, it seems. Where are they coming from though? I covered my bottom roller with nylon pantyhose, so there is no triboelectricity down there because there is only pantyhose on pantyhose action. And why the hell the belt coming down is negative instead of positive? Do the arcs even jump? Okay, let's touch the opposite side going down. Okay. Alright. Now that it's discharging, it's going positive. And touching it on my side, the belt is already negative.
Huh.
Okay, I have a feeling what might be going wrong here. It is possible that the top dome being very negative and naturally charges wanting to escape now found a way to discharge. Perhaps electrons found their way over the sharp edges of the copper plates, bringing the voltage on both sides of the belt down negative. Although, there is still a big voltage difference between the sides. So initially, when the dome voltage is low, the belt going down becomes positive. But as the dome charges up and charges escape, belt voltage becomes negative. In this case, me introducing a ground actually sucks charges away from the dome faster. This makes me think, what if I just remove all these stupid copper plates I put on here? Kudos to their adhesive though. Now I can't even run it at full speed again. Let's see if it is not weaker than before. Ow! Well, it's not weaker if it is not stronger. Oh, I can hear charges running away. Ouch! Now I'll be running it like this and touch the rising side of the belt with my ground, and if the frequency of the arcs changes, it means that we have been successful. So without the ground, we are like this. Tick, 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 tick. And with the ground touching the belt, tick, tick, tick. Okay. Tick. Yo, maybe I'm onto something. How far can it jump now?
Could it have been like something like silly, like, I don't know, like just an alignment thing with how he put each of the little copper Band-Aid looking things on there, like it was not perfectly symmetrical to make that nice, even bounce of charge that he was describing, or the humidity's effect on there. I'm just trying to wonder, like, why those little copper strips seem to cause things to act weird.
Whoa! Well, okay. Whoa, am I actually pumping more charges now? Show me how far can you jump now. Oh my god! So perhaps now the charges are not running away from my copper plates, and perhaps I'm depositing some electrons on the belt going up. It does feel stronger than before, but at the same time, I feel like I would achieve even more if I get rid of these sharp edges on the dome. Like I said, reduce the leakage, increase the voltage. But I was hoping for more. Maybe there is a way. Damn it! I need to think more about this to make it work better, if it is even possible.
I'm sure if anyone can figure it out, he could. Thanks so much for the recommendation, and thanks so much for watching. I'll see you next time.